Olivia.
I'm Jenny.
I'm Hannah. And we're the stars of the latest film, teaching you about physics and refraction and rainbows. I'm in 4th hour.
I'm in 6th hour.
6th hour.
Go physics! Yeah! Honey!
The pencil you see looks bent in this glass of water. Why is that? It is because of a phenomenon called refraction. When light enters water, it cannot move as fast as it does in air. This is due to a change in densities, causing the speed of light to slow down as it moves from a lower density, which is air, to a higher density, water. As light enters water at an angle, it bends away from the normal. The normal is a perpendicular, imaginary line from the surface of a substance. This substance is water in our case. This causes the pencil to appear bent to an observer, and that is why the pencil looks bent in this glass of water, all due to refraction.
Okay, as we showed in the previous video, we have a glass of water with a pencil in it. You may have noticed that, as Hannah described, the pencil inside of the water looks like it's not absolutely connected to the pencil that's outside the water in the air. This is because if this is our water line right here, and this is our vertical normal, as light comes in toward the water, it's traveling at this angle. But when all these beams of light are coming in like this, the beam over here is going to hit the new density, the new material first, so it's going to change directions down here. This one is still traveling at full speed because it's still in the first medium, but as it comes down, eventually it is going to catch up with the second medium, and it's going to change direction as well. But since they're changing direction and they're hitting that new density of medium at different times, that's why the light is going to bend, and you're going to result with a broken-looking object.
Okay, so Olivia previously explained in the last video why we see the pencil bent because of the different angles and mediums it goes through and the different speed change. I'm going to explain to you why we don't see the pencil bent when it's sitting up at a full 180.
Try angling it different.
Alright, so this is our water. So when the light hits it this way and hits it this way, they're traveling at the same speed. And because they're not going at an angle, they'll hit the medium, change at the same speed, and travel down the same speed, causing this pencil to look the same and not bent.
I'm Olivia, and I'm live reporting here in my very own backyard. Here, I'm going to take you to the sunlight. This sunlight is hitting this glass panel right here. I'm going to follow it down all the way to this beautiful rainbow occurring in nature. Do you see it? Do you see its beauty?
Yeah. It's beauty.
This is occurring because the light is hitting this glass. The glass then disperses the white light from the sun into many different wavelengths. Here we have red, orange, yellow, green, indigo, and violet. But we forgot blue. Blue's in there too! Anyway, the glass panel is the one dispersing into these many colors on the color spectrum. And we'll see you next time here on Colors in My Backyard. Here, as we saw outdoors when I was live reporting, we have the sunlight, which is white light, meaning that it contains all of the wavelengths in the color spectrum. So the white light from the sun is going to shine down, and here we've got a prism, which is represented by the glass outside. And in this prism, as the white light comes down, the light is going to disperse into all of the different wavelengths, which is going to be, it's going to show up as many different colors. So first, the longest wavelength is going to be red. Since red is the longest wavelength on the color spectrum, it's going to bend the least. That's why that's going to appear first on top. The second longest wavelength is going to be the orange one right here. That's why it's going to appear right under the red, because it's the second longest. It's going to bend just slightly more than the red wavelength. Again, with yellow, similar thing, just slightly less than the orange. Moving on to green, it's going to bend, again, just like that, a little bit more than the yellow, and so on and so forth. She's going to keep drawing. And notice over here how the red is longer than the orange, which is longer than the yellow, and the green. That's why this length difference within the wavelength of the color colors is why when inside this glass prism, it's going to disperse into all of these different colors. Next we have indigo, and she's going to sum it up with violet, which has the shortest wavelength. So when all these colors are dispersed, we can trace it back to the middle of the prism where the white light was dispersed into all the different colors of the color spectrum.